So today we're going to do a basic overview of driving a larger stepper with an Arduino and coding and basic setup on how to run one of these larger steppers that you need to have a separate driver for. I know there's other videos out there. In fact, one of my favorite guys on YouTube, AVE, just put out one that I watched this morning. This is a little bit different setup just because of some of the hardware I use is a little bit different. For this application, I was looking for something a little more robust than maybe some of the things you'd find on eBay and that kind of stuff. So everything we're going to see today is from a company called Anaheim Automation, and the stepper driver, this box right here that we're using today, this actually has its own built-in AC connection. So you don't have to have a separate power supply. It connects directly to the to AC power there and drives the motor at, I believe it's 24 volts that it drives the stepper at. And then everything on this side is 5 volts from the Arduino. In this case, I've got a Mega. This has also got an Ethernet shield on it. That does not matter. I've also got a little keypad plugged in here for something we're going to show in a minute. But this is just to go over the basics of what we've got and then making it work and showing you the difference. This is a microstep control driver, but you can control basically the dip switches from your Arduino, unlike some of, like the AVE video I watched this morning. You have to go in and set the dip switches, and that makes the adjustment in here. Well, with this, you've got 2 different inputs that basically give you 4 different speed options. So that's kind of what we're going to show here. So going over the hardware, this is the spec sheet on the stepper driver that we're using. It's rated for 1.5 amps. Again, it's got the input directly on it, and this does either a full step or divisions of 2, 4, and 16. So we can control this from the logic in. We're going to use this diagram where basically we've got all the grounds connected together, as you can see on the board here. You could just jump them out there at the connection, and then we're going to supply a pulse signal here. And we've got that hooked up to our Arduino, and we're going to show in the code how we do that and then show on the oscilloscope what that puts out. And our direction, basically this on and off switches whether it goes clockwise or counterclockwise. This turns the unit on and off. For the application I'm actually going to use this for, I need to, basically when it's on, it will hold its position. If you turn it off, it will not try to hold this position, so I need to be able to turn it off to be able to jog manually, I think, what I'm doing with this. And then these are our microstep connections here. Basically, we're going to have a high-low option that give us 4 different speeds by changing the inputs, the positive side inputs to these. And then obviously we've got our AC connections here, and then our 4 connections to the motor phases. This is so these guys sell, this is an industrial supplier, but their prices are pretty good. I mean, obviously, again, not eBay level, but better quality. So we're using a NEMA 23. This is a NEMA 23 motor. The specific one, the specific one is the one I've highlighted right here, the 3Y206D LW8, I believe, is the one that we're working with here. Oh no, I'm sorry, not, because that's a double shaft with it coming out on both sides, so it must be the one right below it, maybe. Anyway, so this is an 8-wire. So you've got 4 different sets here. Basically, to hook an 8-wire up to our 4-wire connection, we've got 2 different options. I've got a page here, basically shows that. So we're basically just going to set this up in a lower power, higher torque setting that we just take all the commons and put them together. So we're running these two phases in series, and then we just end up with a wire coming out on either side. So I've got just janky butt splices in here. So we've got our two commons together, and then we're running our four other. We need to make sure, you need to make sure that you're on the right phase, and because this is a documented motor, we know what the wire colors are to go with each phase. So we've got all these set up, so our 1, 2, 3, and 4 phases are hooked in correctly there. So basically what I've done is, we'll show you the end result. So I've set this up, and we'll go over the programming and what's coming out of it, but I've set it up to run. I've got this keypad here, and basically I've set it up so that it runs at for one revolution at the 4 different speeds. So we'll see if we press 1, that's the slowest setting, and it'll go ahead and do 1 revolution that way. And then that's the next setting up, and the fastest setting. We can adjust that a little bit. I think we're maxed out on clock pulses. I think 5. Should I remember? Yeah, it's maximum. Well, we'll take a look at that. I think we're at the maximum that we can clock this at. But anyway, so we'll go back to the application here. On the other thing I've done with this is, if you take a look at the keypad, I coded it in so that, and we'll show on here on the computer, if you look here at the display window, basically if I press button 1, it checks to see if button 2 is pressed, and then if I press button 2, there's a 1 second delay built in there, and if I press button 2 within that time, then it switches the direction. So now in each of the speeds we run the other direction. So just a little coding idea to throw out there, where if you've got 4 buttons, you can kind of expand that if you need to change modes, where you can press 1 and then trigger another one. You've got to it doesn't have a lot of error correction in it, because you got to hit them within a certain amount of time, and you got to build delays into your coding. But basically by doing that, I've set it up so that now I have kind of 5 buttons, because I can change the, well, no, see, I screwed it up there. So now it saw that I pressed button 1 and I didn't get button 2 pressed in time. The key is you got to press the first button, and then it's got a 1 second delay and then it looks for this. So you gotta press one and then the other kind of fairly quickly. Okay, so you saw on the computer it switched to counterclockwise, so now it's going the other way. So how did we do all this? If we switch over here to, well, we don't have to clear all that out. Switch over here to our code. We've got we're setting up our clock pin, our direction pin, and then these are the pins MS2 and MS1 are basically our dip switches for the speed setting, for our step setting. And then our power pin, that's basically our on and off. And then these are our input pins from the keypad. I've got more inputs because this is a Arduino Mega. So these are running on higher numbers, and maybe you would see with a smaller one. So then we go down to variables. We're setting our direction state. I think this lines up right, that if I have that set to low, it is clockwise and the other one's counterclockwise. I don't know that I went back and checked that after I put that comment in there. We're basically setting our button states. This button 1 isn't used. Button 2 is used later to check the state of that button number 2 for that switching direction. So that's not as important. Pad state, that's just the reading for the start reading for the variables from the buttons on the keypad. And our clock rate, this is the delay between our on and off pulses that we're sending to the clock, the positive clock connection on the driver. So within this, we've got an array here that basically is how many steps basically I made an array for each of the speeds. So at one speed we want to go 3,200 steps. So that's the most steps that we've got in, and that's our slowest speed. So in order to trigger that, we've got 3,200 steps equals 1 revolution, and we've got our dip switches set so it's low and low. And then we go up to the next speed and it's 800 per revolution. And our dip switches, our dip switch 2 is set to low, and our dip switch 1, well, I'm calling them dip switches, but they're not. They're just input switches. Is set to high, so that gives us that switching to that next step level. And then we go to where it takes 400 pulses in order to make, or 400 steps to make a rotation, complete 360 rotation. And we've got MS2 set to high and MS1 set to low. And then we have them both set to high. It only takes 200 steps for it to go all the way around. So that's what we're seeing. I press button 1, we're in this sequence, and it makes that slow turn. And then say we jump all the way to button 4, we're over here where it's calling this 200 steps, and you can see it does it real quick. So then we're going to go down to, we're just declaring our output pins here, and so we've got the clock pin and our various outputs, and then this is the input for the pin pad. Basically, if you haven't used one of these before, it's got 5 connections on it. One of them is ground. So basically, it switches when you press the button. It switches it to ground. It gives it continuity to ground to that pin. So you need to put an input with a pull up, so that when it's not on, the Arduino will read that as high, and then when you press the button and it connects it to ground, it will show it as, it will read as low, so that you can read that button input. So next step down here, we're at the start of our loop, and the first thing we want to check for is that I'm not trying to change the direction. So basically this section right here changes the direction. We've got the state. So what we're doing is we're looping through the keypad buttons. So we're going through the loop of the buttons through those pins that we've got up here. And as we go, so we're going to loop through and read each button and read its button state. And then we're going to, this is switching the output. So when we loop through and we change the direction, on the next one we need to write to that pin to change the direction pin, whether it's high or low. So this is changing that direction pin the next time it loops through. This is set. So now we go down, and if the button state is low, basically meaning that for whichever Z we're incrementing through, if that button is pushed, and if that button is the 0 element in the array, which is button 1, then it's going to come out and it's going to print out to our little our display here. It's going to say check 2. Well, it's going to say check button 2. I edited this after I haven't uploaded, I guess. So it checks button 2. Then we have a delay while it waits basically to let me push that button. And then it checks this button state 2, reads the second, well, Z1, which is button 2, reads the state there. And then if that state is low, meaning that that button is pushed, then it says that it's gonna change the direction. So if the direction is already low, it switches it to high, and it'll comment that out to the display here. If the direction is already high, then it'll switch it to low, and also comment about which way it's going about. And then it puts a little delay in afterwards, and then it just breaks the loop, so it'll come back around to the next time. And then we've changed that direction state, so now that pin's going to switch at this loop. We go back through, if we were to just press 1 or whatever, it will switch the power pin to low. Basically, if it's showing it positive 5 volts, then it that switches it off. So switching it to low will turn it on. So that turns on the driver, and then we're going to write what speed level we're at. So we're recalling our array. We've got the same Z that lines up with our array here and the steps that we're going to use. And then we run a loop through that basically turns our clock pin high and low based on for the number of steps in that step array, again up here at the top. So what does that look like? We'll show on the oscilloscope. Let's see. My GoPro moved here. GoPro's got critically low battery, so we'll hurry. So we've got connected to our clock pin and to ground here with the oscilloscope. So if we watch the signal as we turn it on, that's the clock, that's the output signal that we're getting. And we could go back into the code and change that clock rate right here. If I change this, I mean, you could up it in order to decrease the frequency, but as you can see here on the oscilloscope, we're at 493 hertz. We can drop that down. Let's say go to 0.5. It says that this driver is rated for maximum frequency of 500 kilohertz, so we can increase this. Hopefully I haven't made some silly change that's going to cause this to crash as I upload it. Okay, so it's done uploading, and now I haven't changed anything on the oscilloscope, so we hit the same time. Yeah, see, it's not working. So frequency, see, the frequency that the oscilloscope's seeing is 50 kilohertz, so I don't know. We'll go change that back to 1 and upload. And I don't know if you can hear that, but the motor, when you disconnect, as you reboot the or reload the code into the Arduino, it basically puts that on-off pin to low, and you hear the motor kick on for a second until it starts running the loop. So we're back to, let's see, we press 4. Yeah. So now we're getting back to the same signal on the oscilloscope. Just to show, if we change that clock rate to 10, well, let's change it to 5 because it may not. I might have to adjust the display on the oscilloscope to show it. If that. So uploading, and now you can see and hear the difference. Okay, so that shows us all of our basic code. They do make a library that you can use to run a stepper, but you know, I think it was a little bit different because I had those pins, so I just went ahead and for the different steps. So I went ahead and, oh, there goes the GoPro. I went ahead and just wrote the code manually. And but basically you could set this up to, if you needed to run at different speeds, which I kind of do in this application, I can do that. and have it switch between different modes within, depending on what it's doing in the program. Basically, this machine has a part where it needs to move sort of quickly in one direction and very, very slowly in another. So this will drive onto a larger wheel, and I've got a belt. And we've got to machine up a part in order to get that going. So as soon as we get the coolant in the Tormach mill and get that all done, we'll go ahead and get that machine for a mount for this, and to mount it to the machine, and then have that other pulley connected here. So hopefully this is a good overview of the basics. Again, this is a little bit more expensive equipment than what you might find. There may be something out there, you know, on eBay that's got everything built in that can do some of this stuff, but for this application, I just wanted something robust that I knew, you know, came from a good source, because this will be on something that sort of runs lights out. So I want it to be as robust as possible. I realize I probably shouldn't be using an Arduino for something like that, but that's also part of why this has an Ethernet shield on it, that if it has an issue, it's or different steps in the process, it's going to be able to email me and let me know if there's an issue, so I can come out and deal with it. So that's going to be a wrap for this one, and hopefully you guys enjoyed it. I've got a couple other things we're going to put together and show here over the next few days, but I'll get a bunch of these videos uploaded and have a good time.